This is just a simple understanding of what is happening जब आप solidify करेंगे तो क्या होगा क्या उसके अंदर. And I'm saying that what is happening in the case of eutectic systems. I'm writing it as part 1. Part 1 का meaning अभी बाद में समझाएंगे. पहले let us see that what is happening here. Once I see that when I am above the liquidus line, I have only liquid. In this liquid plus alpha region, ये same phase diagram है जो भी आपने last slide में देखा है. Only thing is now I have putting a part of it here. So when you are in this region, the white region which is liquid plus alpha, तो ये कुछ ऐसा होगा, कुछ liquid है, कुछ alpha है. जब आप यहाँ पे आ गए, which is in a single phase region because now it is within the solid solubility limit, तो ये सिर्फ alpha है. And ये black colored, these are the grain boundaries. So your alpha grains which are having the grain boundaries there. So this is what is happening in the case of your how does the microstructure develop? That from a single phase you go to liquid plus solid and then you come to other one. We will not need this. Let me skip it. Okay. This eutectic point is of interest. We have already explained that in a lead tin system there is a eutectic point available to us here at 61.9%. And इस पे हम कह रहे हैं कि when you are having this composition at this temperature, it will directly solidify from liquid into two-phase solid, that is alpha plus beta. Both of them will start solidifying simultaneously, and that is why we find here that you have a layered structure that is called a lamellar structure. Lamina means layers, because once you start solidifying it just below the eutectic point, you find here that at this point you have a lamellar structure developing. And in this lamellar structure, what is happening now? What I have drawn the tie line again. And at this point, this constitution point, this contains the alpha phase, which is there, maybe the blue phase. It contains 18.3% tin, and the beta phase, which is shown here as the red phase here, it contains 97.8% tin. It is here. I've just read the tie line rule here. So as you keep on decreasing the temperatures, because solidify करेंगे तो और भी नीचे आएंगे. So during this also, what will happen? That things will change. You can draw tie lines. Things will change. What will change? Composition change होगा कि amount भी change होगा कि दोनों change होंगे? Yes. A, when you come to B, at this point, moving from A to B, will it change the composition only or the relative amount also, or both?
Sir,
दोनों change होंगे because you are drawing the tie line here, so the tie line is changing. So मान लीजिए point यहाँ आ गया now at point B, so you have the alpha intersection here and the beta intersection here. अब आप निकाल सकते हैं सिंपली कि अल्फा की कंपोजिशन क्या है और बीटा की कंपोजिशन क्या है. तो यहाँ पे अल्फा की कंपोजिशन आएगी लेट अस से कोई 10% है सपोज, और यहाँ पे बीटा की कंपोजिशन कुछ और है 98% है, और नीचे करोगे तो और होगा. दैट मीन्स ड्यूरिंग दिस सॉलिडिफिकेशन ऑल्सो व्हेन द फेज ट्रांसफॉर्मेशन इज हैपनिंग, यू आर एक्चुअली हैविंग अ मूवमेंट ऑफ एटम्स which is again what we call as diffusion, because atoms move कर रहे हैं. blue वाले region और red वाला region जो हम alpha beta कह रहे हैं, in there those phases the compositions are continuously changing. Their amount is also changing. ज़्यादा हो रहा है, कम हो रहा है. When you move up or down, the things keep on changing. So that is what is known with the help of what we call as your phase diagrams. And eutectic point, normally at eutectic point you have a eutectic microstructure formed, which is a lamellar microstructure. Lamellar means I have shown that layered microstructure. The two phases are available to us in layers. Same thing happens in iron carbon system with at the eutectic point where you have a structure formed as ledebrite, which is having a lamellar structure again. Okay. So we again define the same reaction here, the eutectic reaction, and I will define two more reactions, the eutectoid and the peritectic reaction. We'll only talk about the first two today, eutectic and eutectoid. The eutectic, we have already said that once a single liquid phase on cooling transforms into two solid phases, we say that is a eutectic reaction. And it will happen, it will also be called as the lowest melting point, so it happens at a very low melting point. Similar eutectic reaction is available in the iron carbon system also at around 4% of carbon. The second reaction that is important to us and very important to us in iron carbon system happens to be eutectoid reaction. If you read it carefully, it says that now there is slight difference. There is a slight difference. One solid phase is transforming into two other solid phases. That's what we are saying. Here, eutectic was liquid to alpha plus beta, liquid to two solid phases. In the case of eutectoid, we are saying a single solid phase is transforming into two solid phases, or S2 if I write S2 or S1, whatever you name, give it here, S1 plus S3, and it is a reversible reaction. And again, it will happen. It is also an invariant reaction. Invariant means it will happen only at some particular composition and it will happen at that temperature only. And for FEC system, the temperature at which this happens is 727 and the composition is 0.76% of carbon. So when you add 7.76% of carbon into iron and you go beyond 727, you have at that isotherm of 727, you have this reaction which we say is the eutectoid reaction which is happening. And this is important because this is the basic of heat treatment for steels. So whole of the steel heat treatment that will come up in the next 3-4 lectures is actually based upon this eutectoid reaction. And first thing is right now to understand what is the eutectoid reaction, the definition of that, and then we will go on to that how does it look like in your iron carbon system. So peritectic I will come later on, that what once we go to that we will see that what is the peritectic reaction